algebra students here. Mr. Lawrence here once again. Hi, Zach. How are you? Hope you tell your friend from Willits hello. And we're going to be talking about zero and negative exponents. Now, look, I know most of you don't understand this topic. It's the first time seeing it. You're going to take some guesses and you're going to be wrong. But do me a favor, get your notebook out. Go ahead and take a guess for these three numbers, okay? Now, I'll tell you right off the bat, if you think that these two are negatives, they are not negatives. The exponents are negatives, but the numbers themselves, once you evaluate them, are not negatives. Remember, exponents are different than just plain old multiplication. This is not 2 times negative 1. It's 2 to the negative first power. So you're probably wondering, well, what could it be then? Well, let's take something we know how to do and see if we can apply it to something we're not sure about. Remember, I'm always telling you that's the key to understanding mathematics. And some people want to memorize all these rules, and you know what? There's too many rules to memorize. We've got to master the rules, but just to memorize them, you're going to get them mixed up. Let's always compare something difficult to something we already know how to do, and then see if we can uh, build some understanding. Then we can develop our rules. All right, so I'm going to come down here, 2 to the fourth. Of course, that means, 2 times 2 times 2 times 2, right? And of course, that equals 16. All right, so 2 to the fourth is 16. Well, what's 2 to the third? Well, of course, it's 8, right? And then 2 to the second is 4. 2 to the first is 2. Now, before you start to guess again on 2 to the 0 power, ask yourself, look at this table. How does 16 turn into 8? Well, you divided by 2, didn't you? Yeah, because there's 1 less 2 being multiplied. It's like we divided a 2 out. All right, how would I turn 8 into 4? I divided by 2 again, didn't I? 4 to 2, I divide by 2. If I'm going to go ahead and divide by 2 all the way down, then that means 2 to the 0 must be the same as 2 to the first, 2 to the first divided by 2. Well, if you remember from the last video, we can stick a 1 right there as an exponent. And what do you think 2 to the first divided by 2 to the first is? Well, of course, it's 1. It's got to be 1, right? Any non-zero number divided by itself is 1. So, wow, that was pretty crazy. Huh. Let's see up here, 2 to the 0, that would be a 1. Let's let's test that for a second. What if I had, say, uh, 5 to the first, and I was going to divide it by 5? Because in a table with 5s, 5 to the third, 125, 5 to the second, 25, 5 to the first, 5. I'd be dividing by 5 as I went down. Well, wouldn't that also be 1? Okay, so what you've just discovered is that any non-zero number uh, to the power of 0 is 1. Yeah, any non-zero number raised to the power of 0, raised to the power of 0 is 1. Yeah, can't do it with 0. Why not? Well, if I had 0 to the first, and I went to divide by 0, warning bell should be going off. Danger, Will Robinson, danger, danger, danger. You can never, 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 never divide by 0. You can't. There's no definition for it. I can't do it. You can't do it. Your friend can't do it. Einstein couldn't do it. There is no definition for the division of 0. Division by 0. Excuse me. All right. Now let's use this logic to continue down our table. The negative exponents. A lot of you are thinking this should be a negative number. I don't agree, because if I take this and divide by 2, because I've divided by 2 down the whole column, 1 divided by 2, isn't that the same as 1 divided by 2? or better yet, 1/2. Oh, check that out. 2 to the negative first power is 1/2. And then if I divide that by 2, if I had half of a pie, right, I'm going to get this highlighted yellow half over here. I have half of this pie. Okay, and I'm going to share the other half with you. All right, then you're going to get about this amount, right? Well, if I divide a half by 2 to share with you, hey, I'm a poet and I didn't even know it, don't I get 1/4? So 2 to the negative second is 1/4. Now check this out. This is like too cool because this is really easy stuff. A couple minutes ago, you guys were like, probably had no clue on this, but this is easy stuff. Look at this. 2 to the negative first was 1/2, right? Now check out 2 to the first. 2. All right. How about 2 to the negative second? That's 1/4, but 2 to the second was 4. Do you notice the relationship that they have to each other? Yeah, they're reciprocals of each other, right? A negative exponent means that we're going to use the reciprocal. The fraction is going to flip. You say, but Mr. Lawrence, 4 isn't a fraction. Sure it is. 4 is a fraction. Boom. And then I use the reciprocal. I don't know if I mentioned this to all my classes, but I had a student a couple of years ago. I had a former teacher that liked to call that the reciprocal, just to remind kids what to do with the reciprocal. All right. Now, so we have the reciprocal, and I would like you to see if you can tell me what 2 to the negative third power is. Now, I'll give you a couple seconds to think about it. Do, 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 do. Okay, that's enough time. 2 cubed is 8, right? 2 to the negative third would be 1/8. There we go. So a negative reciprocal means you go ahead and evaluate. 2 to the first is 2, but then you use the reciprocal. 2 to the second, of course, is 4. Then there's a negative exponent, so I use the reciprocal, 1/4. Consequently, what would happen if I had 1/4 to the negative second? Well, 1/4 to the second would be 1/4 times 1/4, which would be 1/16, right? So the negative second would get me 16. I'd use the reciprocal of that one. See, it just goes back and forth. Easy, easy stuff. All right, let's come on down here to this division problem. And when I do it, I'm going to think about it two ways. One, I will think about it as a division problem. So I'm going to write it as 5 squared over 5 to the 4th. And then I'm going to think about it as the numerator is 5 times 5. And my denominator will be 5 times 5 times 5 times 5. Now, I don't expect you to write all this out, but this is something that is happening. These 5's will cancel. These 5's will cancel. Is there anything left in my numerator? Actually, there is. Don't say no, because there's a 1, right? Because when I cancel, there's a 1 left. And so what I have is 1 over 5 times 5, and therefore 1/25. Okay? Now, I'm going to do it a different way for you. That's a very good way to do it. You'll do very well. Nothing wrong with it. Some of you are going to go, hey, this 5 to the second divided by 5 to the negative fourth is the same as the power of 5 to the 2 minus 4. 5 to the power of 2 minus 4, which is 5 to the negative second. Well, 5 to the second is 25. The negative exponent means to use the reciprocal. This must be 1 over 25. And notice we get the same answer. Okay, this example here, x to the 7th divided by x to the 10th. Again, if I had x to the 7th over x to the 10th, wouldn't that be the same as 7 x's canceling with 7 of these x's? So I'll have a 1 in the numerator and an x cubed in the denominator, right? Doing it the subtracting way, x to the 7 minus 10 equals x to the negative third. Well, x to the third looks like that. X to the negative third would be 1 over x to the third. Yeah, there you go. The way you understand it is the way I want you to do it. Okay, let's try a more complicated one here. I'm not going to write this one out both different ways. What I'll do is I'll do this first one using the subtraction method, and I'll do the second one down here doing the division, because this video will get quite long. So I'm going to do 10 divided by 5, and I'm going to get 2. I'm going to get x to the fifth divided by x to the third. That should be x to the second. Now, y to the third divided by y to the eighth would be y to the negative fifth. And then I'm going to have z to the 10th divided by z to the 7th. That would be z to the third. All I did was subtract the exponents. Now, I don't like this negative exponent in my answer. It's the only term that has a negative exponent, so I'm going to use its reciprocal, but we're not going to make this difficult. This guy here has the negative exponent. All that's going to happen is he's going to use the stairs. He's going to go into the denominator. So the 2 has a positive exponent. He stays where he's at. This x has a positive exponent. He'll stay where he's at. The z has a positive exponent. He'll stay where he's at. And the x to the negative, or x to the negative, y to the negative fifth will go into the denominator. And notice the sign of the exponent change signs. Okay, that's one very good way to do this problem. And that is your answer. You cannot tell me what x, y, or z equal because it's not an equation. Okay, this one here, like I said, I'm going to do it as a division problem. Some of this will be a little bit of mental math in my head. Okay, I know that 5/20th is going to simplify, isn't it? It's going to turn into 1/4. So I'm going to have a 1/4. The x divided by x, they're going to cancel out. There's not going to be any x's in my answer. Y to the ninth over y to the seventh. We'll have 9 y's in the numerator, 7 y's in the denominator. They're going to cancel, leaving a y squared in the numerator. Then, with the z's, I'm going to have 4 of these z's in the numerator, but I'm going to have 8 of them in the denominator. And I'm going to clean up my answer a little bit. This 1 is totally unnecessary. So the simplest answer will be 4z to the fourth. And there you go. That's pretty simple stuff, isn't it? Whichever way you prefer to do it. All right, this one I'm going to leave for you to do. Go ahead and pause the video now. Have Mrs. Bell pause it if you're watching it in study hall, and see if you can do this one on your own. After a couple of minutes, go ahead and unpause and you'll see my solution. My solution will be a 2 in the denominator, an x to the first in the numerator, a y squared in the denominator, and a z to the sixth in the numerator. And there we go. All right, that's it for today's lesson. Mr. Lawrence signing off. Have a good night, everybody.